Welcome to day 8. Homework is packet pages 54 and 55. We've got a warm-up, so if you could pause the video, do the warm-up, and then a box will pop up to type in your answer for each of them. So go ahead, pause the video now, do the warm-up on your warm-up sheet, and then when you hit play, box will pop up for you to submit your answers. So in the first one, if we cross multiply, 3 times y is 3y. 7 times 12, that'll give us 84. And when we divide by 3, that's going to give us 28. In the second one, cross multiply, x times x is x squared. 5 times 125 is 625. Take the square root of both sides, and we get x is equal to 25. Now the reason they said x is a side in the triangle, because technically when you take a square root, you need to do plus and minus. Out in front, that doesn't really come into play much in geometry, because we're usually working with sides and angles, which have to be positive. But next year in Algebra 2, that will come back into play. Going to the homework. We only had 2 triangles there, so not much of a mystery which ones you were trying to get similar. I chose to do the parallel lines implies congruent alternate interior angles and getting 2 sets of angles congruent. You could have just done 1 set of those and then done a vertical angles. You get angle similarity postulate. Make sure you have A matching with C, the E's matching, and oops, this should say B, C, E, D here. That should be a D in that spot, sorry. Then we've got our proportions. Make sure the ones you want to multiply are diagonal from each other. So DE and AE diagonal from each other, BE and CE diagonal. You got similar triangles implies proportional sides. And then what we wanted to prove, product of the means equals product of the extremes. In 2, we've only got 2 triangles there. They told us S was a right angle in the given, and then we had perpendicular lines implies right angles implies congruent angles to get the one that I labeled 1 congruent to S. Then they are sharing angle R, so you can do reflexive property. That gives you your angle similarity postulate. I called the first one RDE. And I don't agree with what I labeled the second one. So if I went RDE, we've got to start with R because that's the reflexive. Then I went to D, which is my right angle, so that should go to S. And then E should match with T. So similar to RST. The ones you're trying to multiply need to be diagonal from each other. That's our similar triangles implies proportional sides. And then product of the means equals product of the extremes for our prove step. And the third one, we had lots of triangles here. 1, 2, 3, 4, I count 5 different triangles. So what we do, start out, look at BC, and see if BC is only in one triangle. Well, BC is in multiple triangles, the left-hand right triangle and the huge one. So move on to DA. DA is only in one triangle. It is in DAC. So find which one of the other ones is also in DAC, and that would be AC. Well, then the leftover 2 make up the other one. So that's BCE. So we've got the big, tall right-hand triangle on the left. From our givens, we had AB congruent to BC. Well, why could they be giving us that? That doesn't help us get them similar, but we could do the fact that they told us it was isosceles implies 2 congruent base angles, and knowing which ones were congruent allows us to identify those base angles. So we get angle BCE and angle A, and that's one set of angles congruent. Then you can do your altitude implies perpendicular lines implies right angles, and right angles implies congruent angles. And make sure you're getting those ones that are actually in the triangles, because there were ones also that would have been right angles here and here that we didn't necessarily need. Then to finish it off with our three common steps, angle, angle, similarity, postulate. Similar triangles implies proportional sides. Make sure your sides that are multiplying are diagonal from each other, and then product of the means equals product of the extremes. So we're going to start on page 50. Our topic for today is proportions within right triangles. So here we've got a right triangle given to us, right triangle ABC with a right angle at C. An altitude of a triangle is a segment that's drawn from a vertex and is perpendicular to the opposite side. We saw that in one of our early units this year. Today we're going to look at when the altitude of a right triangle is drawn to form a right angle at the hypotenuse. So here is the altitude we're going to be looking at. So from where the right angle is down to the hypotenuse. And you see that in a picture down on the bottom of page 50. So in this picture, I want you to think about how many different triangles are there. Hopefully you notice there's 3 triangles. We've got this one here. We've got this one here. And then we've got the big one. Well, let's compare the green and the red first. The green and the red each have a right angle, and they also share angle B. So therefore, the green and the red must be similar by angle-angle similarity postulate. Let's compare the blue and the red. They each have a right angle, because this would have to be a right angle here as well. And they each share angle A, so the blue and the red would have to be similar by angle-angle similarity postulate. Well, if the red is similar to both the blue and the green, then the blue and green must be similar to each other. So what do we notice about them? In this box here, we have that all 3 triangles are similar to each other. Because they are similar to each other, therefore we know our sides are proportional. And that is the basis for what we will be doing with this type of picture today. So we're given a right triangle ABC. C is the right angle, and we have CD as perpendicular to AB. They gave us some information and what we want to find. So first thing we always do is label our picture. So AB is 8. It's going over multiple parts, so draw it in with a bracket. AC is 4. And we want to find AD, so we're going to call that X. So there's 3 right triangles here. We're going to have you always draw all 3 of them. If you have separate colors, like if you have colored pencils or different colored pens, they can be helpful for this. So if you wanted to pause the video to get that, you could. So the first triangle I'm going to trace is this one here. I'm going to draw that off to the side. We didn't know any of the sides in that blue triangle, so we can't label any of them. Next one I'm going to trace is this triangle here. And what we're going to do is we're going to tilt it to orient it the same way. So we're going to tilt C down and A up. So these aren't going to be drawn to scale, but the hypotenuse of that one was 4, and the long leg was X. Hypotenuse is across from the right angle. The other 2 are called legs, so you'll hear me often refer to them as the long leg or the short leg. In the green one, the short leg, we didn't know anything about. And then in our big triangle, I'm again going to twist it and orient it in the same way so it's easier to see them matching up. And again, these aren't drawn to scale, just to help us match them up. So in the red triangle, we don't know the short leg. We know the long leg is 4, and then the hypotenuse, that whole thing we know is 8. Well, now from this picture, these pictures, we can hopefully figure out what proportion we should set up in order to solve for X. Well, let's start with X, which is in the green triangle. The only thing that would match with is the 4 in the red triangle. So we go back to the green where we knew 4, and that would match with the 8 in the red triangle. So that sets up our proportion. Just cross multiply and solve to get X now. So that's 8x equals 16. We'll divide by 8, and we get x equals 2. So label your picture, draw your separate triangles, and label those separate triangles using the ideas of hypotenuse, long leg, and short leg. And then set up a proportion to solve for the variable that you want to find. Moving down to the bottom, we have that AD is 2. AB, the whole thing is 18. So that means that we can conclude that this is 16. And we want to find AC, so we'll call that x. So keep in mind these might not be drawn to scale. So really a better scale drawing of it would be something like that, where that's A, D, B, and C. So that's x, that's 2, that's 16, and that's 18. Okay, so that would be a better to scale drawing, but whatever they tell you for the numbers, that's just what you would work with. So let's look at our different triangles. I'm going to do this one red to start. So in that red triangle, the short leg is 16. The long leg and the hypotenuse, we don't have anything labeled for it. I'm going to do this one green, and we've got to tip it to the right so that it will be oriented the same way. We don't know the short leg. The long leg is 2, and the hypotenuse is x. And again, we're just calling them short leg, long leg based on how the lengths of them look in the picture. Their actual numbers might not be that. We just need it to help set up the proportion. So then in the huge triangle, again, we want to tip it so it is oriented the same way as the others. The short leg we don't know. The long leg we're calling x. And the hypotenuse we have is 18. So we're going to set up a proportion. And it looks like the two triangles we should use are the green and the blue, because we have long legs and hypotenuses for those with only one variable out of those spots. So we'll start with the 2, the long leg, and the green one. That should go over x, the long leg, and the blue one. And then we'll go back and do x, the hypotenuse in the green one, over 18, which is the hypotenuse in the blue one. Cross multiplying, we'll get x squared equals 36. The opposite of squaring something is taking the square root, so we just get x is equal to 6. So move into page 52. This one we have to draw the picture. So in right triangle CAD, altitude DS is drawn to the hypotenuse AC. So if AC is the hypotenuse, we know the right angle is at D. So when we do this, basically start where your right angle is going to be, draw one slanted line that's a little steeper, and then draw one that's not as steep. It's important we want to be clear in each of the triangles which one looks like the long leg and the short leg. So there's a right angle, there's a right angle. We identified this had to be D, and then AC was the hypotenuse, and they said the altitude was called S. Now remember, our picture might not be to scale, so the numbers, the longer looking sides might not be the bigger numbers necessarily. So DS, they tell us, is 12. CS exceeds SA by 7. So again, that's not going to match our picture, but we'll call SA X, and therefore this is X plus 7. So let's do our different triangles. Let's start with this one here. I'm going to make it green. So the short leg was called X plus 7. The long leg was called 12, and we didn't know anything for the hypotenuse. I'm going to trace this one as red. The short leg we have is 12. The long leg is X. We don't know anything about the hypotenuse. We'll want to twist and orient that the same way as these. We have nothing for the short leg and the long leg. The hypotenuse would be 2x plus 7. So we've got to find two pairs of sides and two triangles where we only have one variable when we look at those. So we want to look at the green and the red. In those, the long leg and the short leg, the only variable that's there is x. So we'll have our proportion. Maybe we'll start with, we'll say x in the red triangle. That should match with 12 in the green triangle. Go back to the red triangle, we'll have 12, and that matches with x plus 7 in the green triangle. When we cross multiply, we're going to get 144, and then x would have to multiply the whole x plus 7. We'll distribute our x, and that'll be 144 equals x squared plus 7x. This is a quadratic equation where we've got both x squareds and x's, so we need to get everything on one side so it's equal to 0. We like to have a positive x squared, so we'll bring the 144 over to the right, giving us x squared plus 7x minus 144. So in a quadratic, if you have 1 in front of the x squared, the thing we want to think about is what multiplies to negative 144 and adds to 7. So we got to think of things that will multiply to negative 144, but will add to a positive 7. Now, if you're unsure of that, the way for the calculator to help you out is go to a graphs page, do the number you want to multiply to, which for us is negative 144, divide it by x, and then do Control T to look at the table, and these are all of the things that will multiply to negative 144. Well, we've got to scroll through and find one that adds to 7. Well, 1 in negative 144, that's going to be a negative number. 8 and negative 18, that's going to be negative 10. I think that's the one we want right there. 16 and negative 9 will add to 7. So use the calculator to help you out. Again, in the graphs page, do what you want to multiply to divided by x. So this is going to be 0 is equal to x plus 16 we saw, and x minus 9. Then we set them each equal to 0. And then we're going to solve. We'll subtract 16, we get x equals negative 16. Add 9, and we get x equals 9. Well, keep in mind that x represented a length in our triangles. You can't have a negative length, so we'll reject the negative 16, and therefore we just have x equals 9. If we look back, we wanted to find both SA and CS. So SA is what we just found. That's the 9. And then CS is going to be 9 plus 7, so that's 16. So what I'd like you to do is read this and then see if you can draw the picture based on what they tell you. So altitude is drawn to a hypotenuse of a right triangle. So again, when you draw it, draw one of them steep and the other one kind of shallow. That'll make it easier to tell the long legs and short legs. So we have a right angle there, a right angle there. Divides the lengths of the hypotenuse into 4 and 5. So let's call that one 4 and that one 5. What is the length of the altitude? So we're going to call that x. So let's draw out our three triangles. I'm going to start with this one, which I'll do in red. Our short leg is 4, the long leg is x. We don't have anything for the hypotenuse. This one, we've got a tip to the left to match the orientation of the other one. Our short leg is x, our long leg is 5, and we don't have anything labeled for the hypotenuse. And I'll do the big one in blue. Again, we're going to have to tip it and flip it a little to orient it properly. Long leg and short leg, nothing is labeled. Hypotenuse we have is 9. So we've got to find one of those triangles where we have 2 pairs of sides, and there's only one variable within those 2 pairs of sides. So we want the long leg and short leg in the red and the green. So maybe we'll start with the x in the red triangle. That matches with the 5 in the green triangle. Then we'll have the 4 in the red triangle. That matches with the x in the green triangle. So if we cross multiply, we'll get x squared equals 20. We'll take the square root of both sides. If you go to a calculator page and do the square root of 20, notice that doesn't come out nice. So that means we need to do our menu number factor for 20. We get 2 squared times 5. So this is going to be 2 times 2 times 5. Circle any pairs. So the 2 goes out front, just one of them. We have 5 left inside. Moving over to page 53. We have right triangle GYM. MS is the altitude to hypotenuse YG. Take a second, see if you can just draw the triangle based off of the first sentence. So we know the hypotenuse is YG. That means that M must be the right angle. So M is the right angle. We've got Y and we've got G. MS was the altitude. So something like that, if you had switched where Y and G are, that is okay. You'll just have your numbers in the reverse spots on the bottom as we label them. So the length of SY is 5 units longer than the length of GS. So X for this, we'll have X plus 5 for that. So again, it's not drawn to scale, but you just go with how it looks in order to match up the proportion. That's really all we care about. And they also tell us that MS is 6, and we want to find eventually the length of GM. So let's call this Y, because that's what we want to eventually find. So let's start with this triangle here. We've got 6, we've got X plus 5. Don't know the hypotenuse. This one we'll do in green. If we tip it, our short leg is 6, the long leg is X, the hypotenuse is Y. And we'll do blue for the big one. The long leg is Y, the shorter leg we don't know, and 2x plus 5 is the hypotenuse. So what we need to do is we need to set up a proportion that involves 2 sets of sides, but it's only one variable. So the one we'd want to do is the red and the green triangle, and we want to use the short leg and the long leg. So we'll maybe start with the 6 in the red. That matches with the X in the green. Then we'll do the X plus 5 in the red. That matches with the 6 in the green. So if we cross multiply, we'll get 36 equals x times the quantity x plus 5. This is going to be somewhat similar to our last one. Distribute the x. We got x squared plus 5x. Because we have an x squared and an x, we want to get everything on the same side, so it's equal to 0. So we'll subtract the 36 over. We have 1 in front of the x squared. So we want to multiply to negative 36 and add to 5. Well, if you're multiplying to a negative, we know one of them should be a positive and one should be a negative. That's the only way you can multiply to a negative. And then we want it to add to 5. So that would be a positive 9 and a negative 4. If you were unsure of that, you can do the trick in the calculator that I showed you earlier. We'll set those each equal to 0. Subtract the 9 over. We get x equals negative 9. Add the 4 over. We get x equals 4. X represent the side length again, so we'll reject the negative. So we have x equals 4 now. So that means that this side is 4 and this side is 9. But the thing we really wanted to find was GM, which is what we labeled y. So what we're going to do is we're going to work with that green triangle, and we can just do a Pythagorean theorem now. 6 squared plus 4 squared equals y squared. That's 36 plus 16 equals y squared. Add those together, we get 52 equals y squared. Take the square root. Go over to your calculator, test out square root of 52. It's not a perfect square. There's no whole number times itself that gives us 52. So do your menu, number, factor of 52. 2 squared times 13. So we're going to have square root of 2 times 13 is equal to y. We got a pair of 2's, one goes out front. So we have 2 square root of 13 equals y, and that's what we are looking to find, because that is the length of GM. That's it for this video. Have a great rest of your day.